Recently, astronomers found themselves in shock when they discovered a neighboring star's intense and violent demise has damaged its planetary system. It was so severe that the dead star left behind, known as a white dwarf, is currently absorbing debris from both the inner and outer limits of the system. Also, to understand dwarf planet cannibalism better, we must be familiar with some terms like the Kuiper belt and G23844. Before we continue further, be sure to subscribe to our channel, Future Collective, for more amazing videos just like this one. With that out of the way, let's get to it. The Kuiper belt is a circumstellar disk in the outer solar system, extending from the orbit of Neptune at 30 astronomical units (AU) to approximately 50 AU from the Sun. It's similar to the asteroid belt, but is far larger, 20 times as wide and 20 to 200 times as massive. In short, a ring of frozen bodies immediately beyond Neptune's orbit is known as the Kuiper belt. The most well-known Kuiper belt objects are Pluto and Arakoth. G23844. G23844 is a former Sun-like star that has shed its outer layers and stopped burning fuel through nuclear fusion. Now, let's get into the scenario. It all started with a star that functions almost the same as the Sun. It started expanding to become a red giant after its complete hydrogen deprivation. The dying star released the majority of its atmosphere into the encircling void. It was reduced to its core, which was shrinking and cooling, and yes, these kinds of objects are referred to as white dwarfs. Long ago, astronomers hypothesized that the red giant's phase and subsequent shell dumping would cause the star system to become unstable. They discovered a number of white dwarfs that were consuming pieces of planetary and asteroid bodies over the course of their investigations. But G23844 demonstrated how much the size of such occurrences and white dwarfs' capacity to absorb matter are underestimated by scientists. The real extent of the turmoil is shown by NASA's analysis that demonstrates that within the next 100 million years, the star is capable of concurrently capturing and consuming matter from both its close asteroid belt and its distant Kuiper belt-like areas. Although more than 5,000 planetary bodies outside of our solar system have been identified by astronomers, Earth is the only one whose internal structure is something we know about involuntarily. This white dwarf cannibalism offers a rare opportunity to disassemble planets and see what they were made of when they were first formed around the star. According to team member Beth Klein of UCLA's Department of Astronomy, the material's gravitational perturbations onto G23844 are predictive of the building blocks of major planets. According to experts, the final scenario for our Sun will probably resemble what has been observed with G23844 quite a bit in about 5 billion years. The Earth and the inner planets may be fully annihilated during the red giant phase of the Sun. Any element heavier than helium and hydrogen swiftly collapses in white dwarfs, settling in deeper strata close to the core. This is one of their distinctive characteristics. Thus, the presence of any components in a white dwarf spectrum besides hydrogen and helium indicates that some element has just been absorbed. Numerous elements were identified by astronomers through the spectral investigation of G23844. Nitrogen, oxygen, silicon, magnesium, and iron are a few of them. Iron has been found in extremely high concentrations, which suggests that a dwarf has captured metal bodies like asteroid fragments or pieces of stone planets. It's also absorbing an ice-like object similar to those seen in the Kuiper belt at the fringe of the solar system, as witnessed by the exceptionally high nitrogen concentration. Scientists claim the discovery indicates that white dwarfs have a far wider gravitational field than previously thought. They're capable of absorbing planets in very far-off orbits, so a planetary disaster in the solar system could be expected at any time. The discovery is intriguing since it enables the evaluation of exoplanets' chemical makeup. A common theory that holds up is that these objects once delivered water and organic molecules to Earth. We should learn from the G23844 example that such bodies should be abundantly distributed in different star systems to avoid any further formation of more dwarfs. With that, our video has come to an end here. Don't forget to subscribe to our channel, Future Collective, and hit that bell icon for more future-related content. Thank you for watching, and I'll see you in the next video.